Okay, we're going to do the laws of exponents. You guys, we've already kind of talked about it with the orange foldable, but I want to go into it a little further in depth. So when you look at the first part of our foldable, it says multiplying powers with the same base. What do I do when I multiply powers with the same base? I'm going to add the exponents. So you're going to add the exponents. We're going to flip open our foldable. We're going to start out with looking at the algebraic form. So that means that I'm going to say a to the m times a to the n. My bases are the same, so I'm going to add my exponents with multiplication. So I'm saying a m plus n. They are variables. They're not the same, the m and the n, so I'm just going to leave them the way they are. All right, I'm looking at example 1a. It says 7 to the 5th, 7 to the 8th, and then 7 to no power. It's automatically assumed that if there's no power, it is to the first power. So I'm just going to place that 1 there, and then I'm going to rewrite it. All my bases are the same. It's multiplication, so I'm going to add my exponents. Okay? So 5 plus 8, 13, plus 1 is 14. So it is 7 to the 14th power. And this is all I'm asking for you to do, is to get those powers together. All right, let's go to the next one. Example 1b, negative 3 to the second power times negative 3 to the fourth power. I'm going to keep that negative 3. Then we're going to add our exponents, 2 plus 4. 2 plus 4 is 6. So my answer is negative 3 to the 6th power. All right. Looking at the last one, this one is a little bit more difficult. I'm not going to put too much pressure on it because this is something really that we use in Algebra 1. So I'm just going to put that up here that it's for Algebra 1, but I wanted to go over it with you. I know that my x's are the same, but I have a 3, a 12, and in front I'm going to put a 1, and behind I'm putting it a 1. Okay, it's automatically assumed that if there's no number in front of a variable, it is 1. It's automatically assumed that if there is no exponent, it is to the first power. You're going to multiply 3 times 12 times 1, and then my x's are the same. I'm just going to add my exponents, x5 plus 7 plus 1. 3 times 12 is 36. 36 times 1, 36. Bringing my x, 5 plus 7 is 12 plus 1 is 13. So 36x to the 13th power. All right, we're going to go to our IMN to page 21. You should have copied this down. We're going to solve these. Same concept. Multiplying, so I have a to the 3rd times a to the 7th. Multiplication, same basis. Going to add the exponents. 3 plus 7, 7, 8, 9, 10. So it's 8 to the 10th power. And this is all I'm asking for you to do. Okay? The next one, 3 squared times 3 squared. Bases are the same. Going to add our exponents. 2 plus 2 is 4. It's 3 to the 4th power. This is similar to that algebraic one that I showed you. We're going to multiply 2 times 5, and then we're going to say n4 plus 4. 2 times 5 is 10. n4 plus 4 is 8. So 10 to the n8th power, right? Okay, let's go back to our foldable. And we're going to do raising a power to a power. That means that I'm going to have an exponent on the inside of my parentheses and one on the outside. When that happens, I'm going to multiply the exponents. Okay, so let's go ahead and go inside our foldable. I look here, my algebraic means I'm going to have a to the m on the inside, parentheses, and then the n on the outside. Okay, that means that I'm going to say m times n. So it's going to be a m n. All right. Let's go to example 2a, 2 to the 5th, and then I have the third power on the outside of the parentheses. We're going to say 5 times 3 with my exponents. 5 times 3 is 15, so it's 2 to the 15th power. Example 2b, we're going to have 3z squared, and then we have outside the third power. With this, we're going to kind of distribute that third power to the inside components of our parentheses. So that means we're going to say 3 to the third power, and then z squared times 3. Okay? 3 to the third power is 3 times 3, which is 9. 9 times 3 is 27. And then we're going to have z, and then 2 times 3 is 6. So 27z to the 6th power. This last one, ladies and gentlemen, this is above and beyond what you need to know. So we're just going to scratch that out. Okay? Let's move on back to our IMN, page 21, and let's solve. So I have 2 squared, and then I have a 2 to the second power, or squared, on the outside. I'm going to write it as 2, and then 2 times 2. All right, we're multiplying again. We're multiplying those exponents. So 2 times 2 is 4, so my answer is 2 to the 4th power. The next one, 6 to the 3rd, and then on the outside, the 4th power. We're going to say 6, and then 3 times 4. 3 times 4 is 12, so it's 6 to the 12th power. If I look at example 2b, this is similar. I have to distribute that second power to both components inside the parentheses. So I'm going to say 7 squared, and then k to the second power. 7 squared means 7 times 7, which is 49, and then it's just k to the second power. My last one here, I have 2b squared, and then I have to the 4th power on the outside. Distribute that 4th power to both components on the inside of the parentheses. I'm going to say 2 to the 4th, and then b 2 times 4. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, yes, 16. And then we're going to say b, and then 2 times 4 is 8. So it's 16b to the 8th power. All right, let's go to the last component. Okay, with division, powers with the same base, it's kind of similar to the multiplying powers with the same base, but instead of adding, we're going to subtract the exponents. Okay, so I'm going to go inside and open up. We're going to look at our algebraic form. So that means that I have a to the m over a to the n. You are going to say a m minus n. Remember, you're subtracting the numerator from the denominator, m minus n. Numerator always is going to be first. Okay, so let's look at our next one. It says 10 to the 8th over 10 to the 3rd power. We're going to say 10 because our bases are the same, and we're going to go 8 minus 3. 8 minus 3 is 5, so it's 10 to the 5th power. The next one, they kind of threw a loop in there. We got this multiplying powers with the same base first before we can solve with the dividing. So I'm going to say 6, 2 plus 7 over 6 to the 3rd. 2 plus 7, 9. So it's going to be 6 to the 9th power, 6 to the 3rd power. Now I'm going to subtract. So it's 6, 9 minus 3, which is 6 to the 6th power. The last component, we have negative 2x squared y to the 8th over 8x cubed y to the 5th. This again is kind of an algebra 1 concept. I'm just giving you an extra piece of information. This is negative 2 over 8, and then we're going to say x 2 minus 3, and then y 8 minus 5. I can simplify negative 2 over 8 by dividing both the numerator and denominator by 2. So it's negative 1 over 4. X is 2 minus 3, which becomes x to the negative 1. I can't have a negative exponent, so I'm going to bring that down and make him positive. He'll go on to the denominator. And then y, 8 minus 5, is 3. That is a positive number, so he's going to go on to the numerator. Okay, last piece of the puzzle. Let's go ahead and do the dividing component on our IMN. All right, so we're looking at this. If you notice, I have 5 to the 4th and then 5 with no power. If there's not a power, it's automatically assumed it's to the 1st. So I'm going to put a 1 in there. And then I'm going to write 5, 4 minus 1. 4 minus 1 is 3. So it's 5 to the 3rd power. Number 2, 2 to the 4th power over 2 to the 2nd power. Again, you're going to say 4 minus 2, which is 2. So it's 2 squared, or 2 to the 2nd power. Now, if you look at this one, I have 5 over 20 and then n to the 8th over n to the 8th. When you have, we're ignoring this 5 over 20, when you have similar with division or the same components, in this case I have n to the 8th, n to the 8th, that's really saying like 1 divided by 1 is 1. So in this case, n to the 8th divided by n to the 8th is 1. So I'm able just to cancel these out. So I'm left with just 5 over 20. I can simplify by dividing both the numerator and denominator by 5. So 5 divided by 5 is 1, and 20 divided by 5 is 4. So my answer for number 3 is 1 over 4.